And we are live. Hello, everyone. Shall we just start straight away, Gareth?
Yeah, I think so.
Yeah? Okay. So welcome, everyone. My name is Britt, and I'm the marketing manager at Eatron Technologies. We are very excited that you are here with us today for our third Talk to an Expert. Talk to an Expert happen every last Thursdays of the month, apart from today's one. So keep your agendas open. And in case you miss any of them, you can find them on Spotify and on YouTube and on our website. So for those who don't know us, Eatron is an international technology company dedicated to making software-defined vehicles a reality for OEMs worldwide. So our house rules are: if you have any questions throughout this talk, please pop them in the chat and we'll make sure that they get answered at the end. So our expert of today is Gareth, our Director of Software Delivery and Assurance. Hi, Gareth. Could you please introduce yourself?
Hi, I'm Gareth Price. I've been working in the automotive industry for about 25 years now, mostly on safety critical systems, but I have done washing machines and smart cards. I've done a bit of avionics as well. But at Eatron, I'm responsible for the delivery of our high quality, safe, and cyber secure products. This is what we generally term assurance. We're trying to comply with standards primarily to make the product safe, but also high in quality.
Cool, thank you. So in our previous Talk to an Expert, we've talked about battery management system with Christoph, and we've talked about AI with Kamal. Soon we're going to talk about motion control next month, but they need to be safe. So Gareth, how do we achieve that?
It's not a trivial question, is it? I think firstly, you need good safety culture within your organization. We do that at Eatron. We have all of our staff induced into the safety culture. I run a session that's about an hour long for most staff, but the engineering staff obviously have like 4 or 5 hours of induction, as it were. And in fact, Britt, you came on my last session. How did you find it?
I did. I really liked it with all the fun videos. You made it really fun.
It's difficult. It can be a bit of a boring subject. It's not as exciting as the battery, as the motion systems. It's always, oh, let's make this safe. Yeah. So for as well as safety culture, we have some standards out there to help us, standards and guidelines. And we use those because we don't want to reinvent something. It's better to use something that's already out there, that's well tested, than try and invent something from scratch. And these standards tend to be developed by really clever people from all over the world. They come together and they generally come up with an accepted approach to address problems, not just safety, cybersecurity, etc., other things as well. And these are organizations like the the International Standards Organization and the British Standards Institution. These are kind of a couple of examples. But to make something safe, you have to kind of start from the basics, though. So I've talked about ISO. ISO 9001 is a basic quality standard. And why am I talking about quality in the context of safety? Well, when you get quality failures, these cause customer dissatisfaction. They're going to be annoyed that the product isn't working, potentially return it. There could be warranty issues with that. Safety is another level above that. The product is failing, but not only are you disappointing the customer, but you're potentially going to harm them. And that's really bad, right? Nobody wants to harm their customers. So in addition to 9001, we look to other standards like ISO 26262 and ASPICE to help us assure that safety.
Right. And do ISO 26262 and ASPICE tell you what to do then?
Not really. They help you, but
Okay.
they don't give you the technical solutions to your problem. So if you've got a battery management system and you're thinking, okay, what's the hazards associated with a battery? Well, we've all seen it on the news. They catch fire. How do you stop them catching fire? These standards won't tell you how to do that. all they'll do is tell you, these technical solutions, they're not going to give you those. Things like 26262, it's an automotive functional safety standard. It defines the evidence that you need to produce. Key there, evidence. You need to produce some evidence to prove that your system or your product is safe, or as 26262 calls it, free from unreasonable residual risk. That's the terminology they use. But it's agnostic of the product. It doesn't tell you how to make the product safe, just the evidence you need to prove that it is safe. So it might be saying something like we need some kind of failure analysis. In fact, it calls it safety analysis, but it's just failure analysis. It wants you to do that because then you'll understand the failures that are occurring in your product. But it doesn't tell you what you need to do once you've discovered those failures, how to mitigate them. It doesn't tell you how to do that. It tells you need to mitigate them, but not how you're going to achieve that. So, following these standards and guidelines, it's generally accepted as best practice. And again, I'm introducing a new term. Why do I say best practice? Well, functional safety isn't necessarily mandatory. So we don't have to make our products safe. I'm not really saying that. We do in a way because product liability law tells us we have to do that. And if we don't have a safe product, basically we're negligent in that law. And we'll soon find out, in a court of law, we'll be sued and we'll have to pay a fine, or potentially would go to prison if we're really negligent. So basically following these standards like 26262, that'll give us some evidence that our product is safe and some kind of evidence that we've done some due diligence on our products to prove that they're safe. But we've also got another problem. That's just 26262. We also need to use ASPICE. And ASPICE is a process guidance model. In fact, it's also an assessment guidance model. And much like 26262, it doesn't tell you how to design your processes. It just tells you what your processes should look like. So I'm giving you all this, how do you do safety? And telling you, well, I'm going to follow these standards, but they're not going to tell you what to do. They just provide like a framework so that you can, you can develop your product. But it's really down to you how you prove that your product is safe. So, there's other standards out there as well. There's cybersecurity, there's ADAS. There's a lot of standards to follow, and there's more coming every day.
All right, thank you. So actually, I've read through your thought leadership article that you've written recently, and it's coming out very soon. Everyone who's listening, stay tuned. You've mentioned something about being agile without compromising on quality and safety. Could you please elaborate a bit more on that?
Oh, you've picked the evil subject of agile. Yeah, agile has a bit of let's call it a bad rap at the moment in safety. Okay, how do I describe this? Agile methodology, it's about incremental deployment of features over time. So you're updating your product continuously, much like a phone. Oh, I've just mentioned phones now. They're not really safety critical. You don't want to turn it off and on again, really, do you?
Yeah, you can't really treat a car like a mobile phone.
No. Although a lot of companies now want these fully connected vehicles, and it sounds like they're defining vehicles as if they're like phones. I think that's pretty dangerous. It's almost like as dangerous as saying we're using agile. It gets people scared. You've got to go a little bit further and define exactly what you mean by those terms. So I'm going to do that now. For the agile part, those continuous updates aren't really in line with safety, especially when you think of the whole product. The whole product needs to be validated, not just these incremental changes. And that's key because I think you can do agile, and this is what we're doing at Eatron, as long as you're in control. As long as you're in control of the development, if you've got good configuration management, version control, change control, and a testing regime such that you can validate your whole system regularly, then Agile can fit with you, or a form of Agile can fit with you. So And in fact, in continuous integration is also identified as something that you probably need for autonomous systems, because there's an area of autonomous systems that is unknown and potentially unsafe, even after release, because these systems are non-deterministic. So, an example of this would be, an autonomous system that had learned something, but hadn't learned something else. So, a dinosaur on a bike. Would an autonomous system understand what a dinosaur on a bike is? It probably wouldn't, because it probably wouldn't have been given the training data to understand what that is. It might be able to understand that there's a bike and it's on a trajectory towards the vehicle and take some avoiding action, but it wouldn't be able to necessarily classify what that object is or was. And this could be a problem if you're at a carnival. If you're at New Orleans in a carnival, maybe you will see a dinosaur on a bike because it's a guy, wearing a costume cycling towards a carnival. Who knows? So this kind of non-determinism and this kind of agileness is sort of inherent within these intelligent automotive systems. And why am I talking about this? Well, we have artificial intelligence on our battery management systems and our motion control systems. We call it at the edge within the system. We also have it in the cloud, and we also have continuous learning algorithms. So part of our product is non-deterministic in some way. There is an unknown element of it. And we know that this means there is this unknown thing that we need to protect for. So we will need to update it. And we don't know what the hazards are at the vehicle level. We're not a vehicle manufacturer. We tend to supply them. Really, they're the only ones who can really determine what vehicle level hazards are. We can make a good guess. There's a lot of our employees who are ex-OEM staff, but it's kind of outside of our scope. We don't even necessarily produce a whole system.
Oh, I thought we did produce full systems, like our battery management system, providing the hardware and the software. Isn't that a full system?
In a way, it's a full
Okay.
system. We do produce the whole software, the whole hardware, but we don't produce the battery cells. That's not our technology. That's not our expertise. We're not battery cell developers or manufacturers. But yeah, you're right. We produce the hardware and the software for a battery management system. But in some cases we don't even do that. We just produce something like an intelligent SoC software component within an AUTOSAR stack. And sometimes the OEM will share none of the rest of the system with us, just they want this SoC component. Some want us to do more. It's very varied. But in all cases, they want the product to be safe in some way, which is difficult. It's very difficult if you don't have the whole picture of the system. If we're just producing an intelligent SoC component, what if it goes wrong? Is it going to cause hazard at the vehicle level? Some customers will tell us, yes, we require it to react like this in the presence of failures. Others say, don't worry about it, we'll deal with that. For us, we have to be very flexible and adaptable.
All right, amazing. Thank you, Gareth, for your time today and for this lovely talk. I've learned a lot, so thank you. The questions are coming in. Are you ready to answer them?
Let me just move my screen around so I can see them as they arrive. There we go. So I'm not looking off to the side.
So we've got Hardeep saying, do you think there are any areas of the ASPICE/ISO 26262 standards that need to be updated, considering the evolving technologies being used in the development of connected autonomous vehicles?
Oh wow, thanks, Hardeep. That's a great question. Yeah, you could update these standards. You could go into 26262 and say, okay, we're going to add these extra parts to it to cope with these kind of scenarios or technologies or use cases. What I'm seeing in the industry is actually people producing other standards. So they're not putting the information into 26262 or ASPICE or anything that is currently existing. They're creating a new standard. And that's a bit scary for me, because now I have 15, 20, 30, as every year there's another standard that's coming out, and it's a part of the it's identifying something that somebody's got a problem with that they want a solution for. So a good example of that would be something like, let me think, safe use of AI and machine learning. So there's a new standard out there, I think it's ISO 8800, that's about artificial intelligence. But then there's another standard about verification and validation of autonomous systems. And I'm thinking, well, the safe use of AI and the validation of those, aren't they connected? Well, they're two different standards. So I would love it if everything was in one place, but it never will be. And in fact, a couple of the conferences I've been at recently, I say recently, prior to COVID, we've covered that kind of explosion of standards and how you deal with it. And it is becoming more and more problematic, especially as these very intelligent things come along and somebody needs some guidance. What are they going to do? They're going to write some kind of standard for it, for the reasons I gave in the speech. It's if it's taken as being the best practice, then in some ways you can say, look, I've followed this. This is the way I've done it. Unfortunately, there's lots of competing standards. Sometimes they overlap, and it's very difficult to know, where those overlaps are and what I need to do to satisfy, to make sure things are safe, not as only safe, but high quality, etc.
All right, I hope that answered your question, Hardy. Let's go on to the next one. He is saying, how much do ASPICE and ISO 26262 overlap? Do you need to do redundant work to comply with both in overlapping areas? And what would be the efficient way of approaching this?
Okay. Unfortunately, there isn't a standard out there that tells you how you. Oh, there is actually the Swedish Standards Institute released a paper on how to merge ASPICE 26262 together. It's really good actually, because it didn't say anything new. It didn't say you need to do you need to do more. It said basically, here are the overlaps. You can do one of these things and actually satisfy both standards. For ASPICE and 26262, they both have a V model. So they both they both have the system part and the software part within them. So there's a lot of overlap there. There's a few more requirements within 26262. I mean, 262 talks about safety, talks about hazards and mitigating them. So you need some safety mechanisms. ASPICE doesn't tell you about safety mechanisms. It just describes a way of running a process to develop a system design, not necessarily a system design that has safety mechanisms in it. So there's a lot of commonality. In effect, there's a lot of that isn't common. So there's no hardware in ASPICE, although there is hardware SPICE. So there is another process model that you could use, another standard. It doesn't cover the concept level in 26262. So the item definition, the hazard analysis, the functional safety concept, ASPICE doesn't cover that. But what we've done, okay, slightly out of context for us, because we tend to be a tier one, we're not a vehicle manufacturer, so we don't tend to do a HARA. Our HARAs are what are called safety element out of context, or assumed HARAs, because we haven't got the vehicle. What we've done is we've created some process descriptions in the style of an ASPICE process description that covers those missing elements, the hardware elements, and this concept layer, and other things like the safety analysis, the FMEAs and FTAs, the processes that we've written for those sort of look like they've been written by the ASPICE committee. I hope
Awesome.
that answers it.
Me too.
I got somebody else asking about the overlaps as well.
Oh, yeah, for us.
So if we got an overlap, I always have a problem with terminology. I'll give you one example. The term component, unit, and what's the other one? Component, unit, and element. Those three terms are used in ASPICE and 26262 to mean different things. That's really frustrating, because the unit is the lowest level of design in 26262. It looks like the unit in ASPICE is actually your implementation of that lowest level of design, or is it? This is the confusion. They are slightly misaligned. I call it the tip of the V problem. It's right when you come to something that really exists, a piece of software or a piece of hardware, there's a problem there because they don't quite align. But all you need to do is align them yourself. Again, I didn't say this in the talk earlier, but these standards are guidelines. They're not there to be followed. I'd say religiously, but maybe that's politically incorrect. They're there as guidance. Really, it's down to individuals or companies to decide how they're going to approach these problems with the help of that guidance, rather than just trying to follow it blindly. That kind of defeats the object. I think one of my colleagues said, you just engage your brain, keep it engaged. Think about the problem, think about the arguing how you believe it's safe, providing the evidence for that, and use those standards as help to speed you up in developing. I said that at the beginning. Don't reinvent anything. If there's good stuff in there, reuse it. Don't use it because it's too difficult. That's not an option. If it's too difficult, try and find another way of doing it. Don't just say, it's too difficult, I'm not going to do that. It's that cost quality triangle of doom, with quality and safety being in the same area. You're always pulling one way or the other to try and get things done quickly. Well, it's not going to be good quality. It's probably not going to be as safe as you want, etc.
Awesome. Annette.
Another question.
Annette's asking, you've mentioned cybersecurity. This has traditionally not been an automotive field, but with the industry heading towards software-defined vehicles, will we see functional safety and cybersecurity merging? After all, cybersecurity can be directly responsible for safety of the vehicle.
Absolutely. There is a standard out there about cybersecurity. Again, I'm going to say terminology. The terminology in the cybersecurity standard sometimes conflicts with the terminology in 26262. They're not perfectly aligned. But again, they both have V models in them. You can see some commonality. Similarly with the SOTIF standard, the ADAS system type standard, they all follow a similar pattern, most likely because it's a reliable pattern to follow in terms of abstracting your levels of development. I don't think they'll be merged. There's two separate standards there at the moment. And strangely, in fact, the FUSA requirements, I said this in the beginning, it's not mandatory. There's no regulations telling you have to follow 26262 and make your system safe. It's all covered by product liability law. For cybersecurity, though, there is a regulation. I think there's a UNECE regulation coming out soon, possibly out now, that stipulates that you must have a cybersecurity concept. Doesn't tell you to use the ISO standard, but says you must have this thing. And actually, if you want type approval for your vehicle, you will have to show evidence that you have it. And guess what's happened now? Somebody's had to write a standard on how you would audit cybersecurity. So we've got another standard out there, EP. So I don't think they'll ever merge. At some point, I'm hoping somebody does a big diagram of how all of these standards fit together. Maybe that's actually a university project, because I can't imagine a commercial entity wanting to do that, the amount of time it would take.
Thank you. Munir is saying, what requirements/configuration/change management tools would you recommend to be ISO 26262 compliant?
Oh, that's an interesting one. I wouldn't suggest a tool will make you compliant. Simple as that. I have a thing about tools. I really like them. I like it when they make my life easier and more efficient. But what I tend to say is, if you're using a tool and somebody sold it to you as being 26262 compliant, be very wary. First of all, they're selling you a dream. You still have to somehow qualify it. That may be using the safety manual that they provided or the qualification kit that they provided, but you still have to check that it's usable. I would suggest don't go about it like that. Write down what you want to do. I want to write requirements. Okay, I'm going to write requirements. I want to link those requirements to requirements further down a level of abstraction. Okay, so I need to trace between requirements. And I'm writing all these things down, and then I'll look for a tool that satisfies those needs. So I'm not going to suggest a tool to use. I'm not going to tell you about the tools we use. I'm quite happy with them, but I'm not going to try and sell you them, because I always think that's a bad thing. Choose the tool that's right for what you want to do. Work out what you want to do, then look for a tool. If you go out there looking to tool vendors, asking them, they'll sell you the world. They'll sell you the tool that will do everything. And it probably won't satisfy you because you don't know what you want from it. So I'd say write down what you want for it, then go and look for a tool, because then you'll find probably the one you want. That's a life
Hopefully.
lesson though, isn't it? You know, if you're looking for a car, don't just go out there. Write down a list. If you're going to buy a house, I don't do any of these things, by the way, in real life. I only do them in my professional life.
I hope that helped, Munir. Paul is saying, with an agile life cycle, how would you manage late incremental change in the features, functions, and requirements and their impact on safety analysis to ensure no unacceptable risk?
Well, you have to do the analysis again, right? And if you have enough time, you'll have a design that enables you to do that. So you'll try and preempt feature addition. So you'll look at your design at the beginning and say, okay, which areas of my design are likely to change? I'll try and put those in a box and define the interface very well on them so that I can change them without affecting the rest of the system. If you just do a flat design and everything connects to everything else, then yeah, it's going to be really difficult to add a feature at a later date without having to analyze the whole system again. So for me, it's a bit like trying to predict the future, trying to work out, okay, where is this system going to be updated? What features are we expecting to come our way? And trying to design the system such that those areas are coherent and have low coupling with the rest of your system. I mean, that's a general principle anyway with these designs. They should be highly cohesive with low coupling. But again, I would try to be choosing the areas that I'm expecting to be updated. That said, you know, if you do a change and you find out it affects your whole system, well, you just have to do that analysis again. And then maybe a tool will help you, right? Because you're going to use a tool. You're not going to do that on paper. So hopefully the tool helps you. But again, I think this goes back to what I said about change control, configuration management. You need control over those, because without them, you won't be able to do anything. You won't be able to change anything ever without knowing what the effect is. I hope that answers. Thanks for that, Paul.
We've got one more question.
Only one.
it's probably typing up. ASPICE and model-based development sometimes not quite align. What is your suggesting for finding the optimum?
Yeah, I'd agree with this. There is model-based development. If you're using Simulink or SysML or anything like that. In fact, the version 2 of ISO 26262 had a really nice section in part 10. It was informative, but it described, you know, the things that you should consider if you're using model-based development to develop your product. ASPICE hasn't done that. There is a bit about model-based development, but it becomes very difficult. There's base practices within ASPICE that specifically say things about the implementation of your design. And usually implementation means somebody hand coding, you know, sitting down there and looking at a design and then coding it, typing in the C code, the C++, whatever it is, Ada, who knows. ASPICE, if you're using modeling, you don't have somebody sitting down. You have a button that you're going to press, and the tool that you're using will generate the code. So there's a disconnect there between some of the base practices in ASPICE and, you know, the fact that you're hitting a button. You need to just consider that that's happening in a phase of development and do something about it. Say, okay, how am I going to add the information that I'm missing from the implementation? Maybe you look at what the model actually generates and you do some work in that domain. Maybe you try to imagine that your detailed design is also your implementation. I think that's what a lot of people do. They just say detailed design is the implementation. I need to satisfy those parts within it. So that would be my suggestion. Yeah. What is your suggestion for finding the optimum? Don't go full modeling. Don't go full non-modeling. You need somewhere in between. The model, most of these models aren't going to give you everything. Simulink great, but there's no dynamic behavior explicitly defined in it. There's always a criteria for defining the loading of the processor, for example. There's no symbolism of that in the Simulink model. You're going to have to write something down. Now, you could decide, I'm going to write that at the top level and just say, actually, I'm going to spin back up to the software requirements and I'll write all of the requirements there. Maybe that's how you want to do it.
Thank you.
I probably didn't answer the question.
I hope
Are we getting
I did.
more? There's a couple more.
Yeah, we do. Alexander is saying, as OTA functionality becomes more and more important, are there any strategies or approaches that can help to make validation and release easier? For example, could we split software in a way that allows updating a partial portion of the code that was not safety relevant? Sorry.
Yeah, I mean, if you have got partitioning of your code, you could possibly do that. I mean, this is a common design pattern. I think it first came out in eGas, although it could have been done by the MISRA team. Might just be a good design where you take your core function, drive the vehicle, whatever it is, and then you wrap it in safety. You say, okay, I'm going to look at what the vehicle's doing and deduce when it's doing something it shouldn't be doing. So a good example would be, I know, if you put your foot on the accelerator and no torque comes out of the engine, you don't know where the failure is, but you could probably say, well, somebody's pressing the accelerator and I'm getting no drive, so there is a failure here. That's that kind of wrap it in. So if you can partition your system like that and say, actually, these are all my safety mechanisms, they're looking at the misbehavior of the intended function, and you put them somewhere where you can update that area in isolation of everything else, then maybe that's a partition system. Maybe that's in fact what you're designing is a system of system, but within the software realms. I don't see why that's not possible. I'm not sure if the background to that, like AutoSAR, I know AutoSAR has these kind of virtual functions, but it's complicated to actually do that in itself. If you've got the ecosystem there, you've got the hardware platform, you've got the software on there, and you've got the capability to do that, it's probably very easy. That's more like a mobile phone. Don't say mobile phone. But yeah, you need to have an architecture that supports that, and I think that's the difficulty, coming up with that architecture that will support that functionality. But I don't see why it's not possible. It's just whether you want to spend your time doing that, creating that architecture, or whether you want to spend the time analyzing the changes that you're making. Both are going to take you some time. I'd say if you've got the architecture there, that gives you benefits in the future, obviously, because you don't need to validate so much. But then the time it takes you to produce that architecture may not be as beneficial as you think. So you've got to weigh up whether that's actually more beneficial than doing the full validation at a later stage. If you're doing lots of updates, it's probably a good idea to try and create an architecture that supports that.
Awesome. We've got one more. We're already going slightly a bit over time, so one more. If anyone else has a question, type it quickly, and then maybe Gareth will answer it.
I'm available at other times as well.
We can actually put them in the chat, and then Gareth will answer them at a later time.
I'm going to a conference at the end of April. The conferences have disappeared. They've finally started again. And there's one in Berlin, the IQPC conference, and a group of fellow safety professionals, mad people who love safety. We're holding a special focus day as part of that conference to talk about things like this. In fact, my thing is going to be the pain points of 26262. And one of the pain points is going to be, what is a unit? Another one's going to be, what is an item? So it's that kind of, altruistic type questions, and hopefully interactive as well. So please come along and ask questions in the future as well. But let's do these two.
All right. Siva Kumar is saying, is there a dedicated ISO 26262 team benchmarked all automotive systems and defined ASIL level?
The ASIL level.
ASIL,
I think I know what he means. So yeah, if you for me, being an Eatron and as a tier one, I'm not an OEM. So the ASIL level is the rating of the hazardous nature of your product. So if I'm doing a braking system and the braking system fails, it's pretty disastrous. So that's the highest hazard, ASIL D. But there's certain scenarios you rate the ASIL based on the exposure to the driving scenario. You know, how often are you driving like that, such that if that failure occurred, it would be dangerous. So that's exposure. Severity, how damaging would the accident be? And the third one is controllability. If it happens, if these failures happen, how controllable would it be? And you add these things together and they come up with this ASIL rating. Now that's pretty difficult for us as a tier one. How often is the vehicle in a driving scenario? I'm not the vehicle manufacturer, I don't know that. How severe is the accident? I don't know. How controllable is it? Or maybe I can say something about that because I know the application, you know, I know what it is. But again, so these things haven't been standardized. You still have to do these calculations. In fact, part of the calculation has been standardized by the VDA, the German group of automotive manufacturers. They've agreed with a set of exposure ratings. So, you know, how often are you on the main road? They'd say that's very often E3. There's only 4 levels. They've actually standardized that in some way. I don't think that document's in English at the moment. I'm sorry, I only speak English, so I'm having problems translating it. The rest of the severity, you can probably get the severity ratings from statistical information about road accidents. Controllability, now that's a difficult one. You know, that is kind of based on the vehicle, but it would be nice if we could get together as a team, i.e. the whole 26262 community, and decide on a set of generic ASIL ratings within certain scenarios as the basis to say this is general for a general vehicle. If you've got a specific vehicle, i.e. it's very fast or it's nimble or it's different, then maybe you should reconsider these ratings. And I don't think that's a problem because there's only 5 ratings, you know. Is it really dangerous? And there's 3 others too. It's not dangerous at all kind of thing. It's like, surely with that level of granularity, we should be able to decide on a common set. But I know there's a lot of pushback. I've always said this, why don't we do it? And every time I say it, I see lots of people looking at me like, not going to happen, Gareth. Just leave that one behind, walk away. So I'd like it. I doubt it'll happen.
Cool. We've got 3 more questions, Gareth.
Excellent.
Annette asking another question, which is great. She says, which part of ISO 26262 do you think require the most urgent changes in the upcoming 3rd edition of the standard?
I'm happy with it as it is. It's not, you know, it's not perfect, and I'm sure version 3 won't be perfect. In fact, the only thing, the most urgent thing that I want in version 3 is it to be free for me because I've bought version 2. I don't want to keep having to buy versions. I don't know. I know. I'd like the ASILs to be standardized, please. I know I'm not going to get that. It'll be an improvement. You know, there will be things that are improved. I'd like more information about how to structure a safety case argument. I don't think there's enough information in there at the moment. There's a lot about other things like hardware metrics, lots of information there, but nothing that really fleshes out what they mean by an argument. It would be nice if they reference the MISRA standard for that. By the way, I'm plugging something that I was working with, a group of guys I was working with. So yeah, I don't know.
Great. Sarah is saying how FMEA analysis should look like for hardware and software design. How deep should this analysis be? And if company doesn't have a proper tool for this, how to perform it?
Okay, so you can do an FMEA with an Excel spreadsheet if you like. I'd say for the hardware, it depends. So if you've got a low ASILed product, so it's not that hazardous, you probably don't need to do the hardware metrics. So you don't need to go to the part level. You don't need to go to the individual part level. You should make up your mind whether that is true. Again, that's my kind of disclaimer. You need to look at what your system is and work out if you really need to do the hardware metrics. You might not need to. If you don't, you need to have an argument of why you're not doing it. That's my disclaimer. So generally, if you don't want to go down to the part, well, something within the hardware architecture, where at the lowest level that you go to within your hardware architecture, I'm using inverted commas for whatever that is, that would probably be sufficient. You wouldn't need to go into, components, resistors, etc. But it all depends on the ASIL, and it all depends on the kind of hazards that you're expecting. You might do it anyway because you want a high quality product. I'm kind of moving away from safety now and saying this is quality as well. You don't want the product to fail and be useless. You want it to be robust. You want it to be, still operate in the presence of failures. You want that as a product because then it is, it's more usable. So if the company didn't have a proper tool, how would it be performed? Yeah, you could do it in an Excel spreadsheet. How deep the analysis? So for software, I think FMEAs don't work for me. I prefer to do the dependent failure analysis because I know that I've got a software component. I purposely use the term component. Let's call it artifact. A software artifact, because nobody else has used that term, that you want to analyze. Okay, well, you need to analyze its failure. If it's used by a lot of your functionality, then maybe you need to do a dependent failure analysis on it. So to see, and 26262 has that in its version 2, it has some guidance on how to do that.
And let's move on to our last, hope it answers Sarah's question. Let's move on to our last question. With AI-based algorithms, actually it is hard to cover all the edge cases since there are possibly lots of unknown. But with methodology, you suggest to decrease the unknown areas on safety domain?
Oh, so which methodology? I don't know. I don't know. Pick one. I'm not going to be forced to choose one. It's going to be a mixture of real world testing and simulation. That's all I can say. You're probably going to do a lot of simulation because you just don't, it's the billion mile problem, to have that many vehicles on the road for that long. It's going to take you a decade to prove out your system, which is just unviable, right? It's going to take you 10 years before you can prove that system can be used on the roads. And every time you change it, you need another 10 years, let's say. That's impossible, right? That's just not a viable product. So you're going to have to simulate. And then, I need to validate the simulation as well. Okay, maybe we should focus on doing a lot of work over in that department because we can simulate quicker than we can do real world tests. So the tie-up between the two, I mean, I've heard in conference again, somebody saying we've done 10,000 kilometers real world testing, but 1 million in simulation. This was for a low integrity, let's call it, ADAS system, something like adaptive cruise control. I did ask them, well, why did you choose those numbers? They said, I can't tell you, it's our IP, but that's what we decided was a suitable limit. So again, I can't tell you. We've chosen something, but I'm not going to divulge that because that's our IP. And there are tools out there and methodology that you can use that's publicly available. And again, I always think if it's publicly available, go to that first, because if lots of people are using it, it sort of becomes some kind of, they call it state of the art. It becomes acceptable that that's a good way of doing it. And if in doubt, go and sponsor a graduate or a student to do the research, because there's a lot of research that needs to be done to prove out these things. And students are really good at these kind of jobs.
Awesome. We've got one more question if you have time to answer it. Sinan is saying, can the memory management cause problem for functional safety?
Anything can cause problems for functional safety. Depends what context it's in. So yeah, if the memory gets corrupted, my throttle limit may be disabled, and therefore I'm looking, maybe I've decided that my controllability limit is 1,000 Newton meters or whatever it is of torque, and my memory goes wrong, and now that limit's set to 2000. So I've doubled it because there's been a corruption of the memory. So yeah, it can. That doesn't necessarily mean you have to develop your memory management unit to be high integrity. You've just got to make sure that whatever's checking it is high integrity and there's no common cause failures. So yeah, anything can cause a safety failure, right? Until you've analyzed it, everything causes a safety failure until you can prove that it won't. That's the key, right? I mean, when we do our issue management at Eatron, it's a safety problem tick box is automatically ticked. You have to physically untick it, and the person who unticks it, we know who that is. So if people start unticking things and saying, that's not safety related, we know about it. And as part of our development is to say, why did you do that? You shouldn't be doing that, or maybe you should be doing that. That was a good choice. You understand this situation. Excellent.
Awesome. Thank you so much, Gareth, and even for staying a bit longer. I've learned a lot today, so thank you. And thank you for everyone who has joined this talk and who has asked questions, and we hope to see you in the next one. Thank you.
Yeah, thank you very much. Cheers,
Bye.
guys.